Hello everyone. In this video, I'm going to walk through question 10 of part 1 of our RF microwave homework assignments. In these questions, we need to use the Smith charts to design a aerometric network which can match the low impedance 100 plus 20, and then we match it all the way to 50 ohm. The question did not dictate which topology you are going to use, whether it's high pass or low pass. You just need to do it. And I presume that we need to disclose two solutions. Okay, so now I'm going to stop the screen sharing, and then you are all looking at the Smith chart. So to begin with, let's write down the details. ZL is 100 plus J40. And obviously, after normalization, you get 2 plus J 0.4. So the first thing that we will do is to locate the point 2 plus J4. This is 2 and J4. So it is here. So let's call this point A. Now, 100 is obviously bigger than 50. So in this case, the first network that you are going to implement is the parallel network, which will be in parallel. The parallel element will be shunt with the low impedance. You have two choices. You can either use a capacitance network or inductive network. So if you move this way, drag along this locus until you reach the 1 plus J circle. Let's say we get the intersection point here, you can call it B. So in this case, your locus will be like this. You need to count how much subsistence that you will use in order to bring from A to B. So if you look at here, focusing on the blue grid, it is 0.1, and if you look at here, focusing on the blue grid, it is 0.5. So from here to here, you will need 0.5 minus 0.1. So altogether, you will need 0.4 J in order to bring you from A to B. But B is not the final point. You need another series reactant to cancel off the reactants. Right now, the reactance here is 1. Yeah, you can see the 1. You need to bring it down to here. From here to here, you need J1. So in other words, Your solution in normalized form will be low. The low will be let's make it big. 2 plus J 0.4. And in parallel with this, you need a subsectant J 0.4. And in series, you need 1 J1. So this is your matching network, arrow matching network. And by looking in here, then you will get 1. 1 means 50. Normalized value of 1 is equal to 50. So from here, you will work out the inductance and the capacitance. So inductance first, you need J, you need 0.4. So from my calculation, you need 0.4, and the value of inductance that you will need is omega L. And this is just a normalized value. So I presume you need to move divided by 50 to denormalize it. Okay, so L will be omega and then 0.4 and then times 50, and then omega is 2 pi and then 3.6 times this, and then you multiply by 0.4. So if you do it very carefully, you'll get the answer. Let me check the answer first. 50 divided by 2 divided by pi divided by 3.6. And divided by 0.4 times 50. So it's 5.53 nanohenry. 5.53 nanohenry. So in order to get this matching network, well, you need the here to be 5.53 nanohenry. Now we are going to work out the capacitance. The capacitance will be 1 over C, and then 1 K1 is 50. So in this case, C will be omega times 50, which is equals to 2 pi 3.6 times 10 to the power 9 and then times 50. So by looking into here, I got 3.6 and then 50. So it's 0.884 picofarad. So this will be the first solution that you can get out of this methodology. Now, having said that, when I say first solution, what it means is there will be another solution. For this solution, you will need a inductor here. The inductor here is, yeah, it's like this, yeah. So inductor 100 plus 340. You need inductor here 5.5V nano. And you need a capacitor here. The capacitor here, according to here, is 0.884 picofarad. So by looking into here, you get 50 ohm. So this is the first solution. The second solution will depends on how you match. You have to go in the opposite direction. Let me check the pen. The second solution, you will need to go from here and then in the opposite direction until you reach the 1 plus J circle. So let's say this is B pump. You need to calculate how much in subsectant you will need in order to get into this one. So by looking into here, here is 1 and here is 1.5. So altogether, you need 6.016J. And from here to here, you need 1J. 1J. So now you need a network like this. J1 and then J6 and then 2 plus J0.4. So this is the network you need, and then you need to use capacitance instead of inductor to substitute this value. And you need inductor to build with this value. I presume here is minus. Here is still plus, but here is inductor. Well, anyway, we will try it. So first of all, 6 and then normalized value of 50 will be equals to, we need the capacitance. So omega C. So C will be equals to 650 and then 2 pi F. F, right? I will just put it here. F means 3.6 giga. So if you do a calculation, 6, you will get 6 divided by 50 divided by 2 divided by pi divided by 3.6 and then to the power 9. So it's bracket. So I got 5.3 pico. And I'm going to calculate this one. For this one, you need an inductor. So omega L, and then you need to denormalize it. 1 times 50. Again, L will be 50 divided by omega. I'll move it a little bit up. And then 2 pi f. Yeah, this is the value. Let's check it. 50 divided by 2 divided by pi and divided by 3.6 and divided by 10 to the power 9. So 2.21 nanohenry. So the other solution will be based on inductor series inductor and shunt capacitor. 100 plus J 40, and in this case 5.3 P and 2.21 nanohenry. So if you look into here, then it will be 50 ohm. So we have two solutions, yeah. This is one, and the other solution is here, 2. Okay. 5.5 nano and 0.88. So yeah, there are two solutions. Okay. You have any question? Please leave the question to the comment section of your video, of this video. Sorry. So other than that, thank you for your attention. Bye bye.